Welcome back to Chapter 7. We're halfway through the chapter already. Can you believe that? We've got 5 important theorems to talk about in this lesson. Most of them deal with proportions and triangles. So remember, our key word this whole chapter is proportions. Proportion. The first theorem is talking about triangle proportionality. And what that means is if you start out with two lines that are parallel within a triangle, then what that does is it's going to divide your triangles into proportional side lengths. So what does that mean? That means if BE and CD are parallel. So let's write that down. If BE is parallel to CD, what that creates is a proportion between AB, AE, BC, and ED. So if these are parallel, then the ratio of AB and BC, that is going to be proportional to this side, this relationship, AE and ED. That's theorem 7.5. As with most theorems, you have a converse. In other words, your if and then are going to flip places. Instead of starting out with two lines that are parallel, we're going to end with two lines that are parallel. So if our sides are proportional, then our lines are parallel. So what does that mean? That means if this ratio of BE over EA is proportional to BD and DC, what that means is that then these lines right here will be parallel. So ED will then be parallel to AC. So these two are related. The only difference is what are you starting out with? It's very important to know what are you starting with, what are you ending with. That's how you know which one to go do. This third theorem that we're going to talk about is called mid-segment. So it's kind of like midpoint. What you have is a mid-segment of a triangle, which means J and K have to be midpoints of these sides. So if J and K are midpoints to FH and this side over here, HG, then what that creates, and we have an and. So we have another condition. Not only do these have to be midpoints, we have an and. Another condition is we have to have parallel lines. So and JK is parallel to FG. If that's true, what we will have is that creates this length right here of JK being half the length of FG. Go another one, please. So then we have JK is going to be 1/2 the length of FG. Important theorem right there. We're going to use that a lot this section. Okay, number 4, proportional parts of parallel lines. So we have 3 parallel lines here in our example, and we have 2 different transversals that are cut. So this is starting off with saying if you have parallel lines. So if AE is parallel to BF, which is also parallel to CG, all 3 of these are parallel. If that's true, then what you have is a proportion that this ratio of AB to BC, that is going to be proportional to this other side of EF and FG. Okay? Okay, one more theorem. It's very similar, but this time we're talking about congruent parts. So this is now a corollary. Remember, that's different than a theorem. So this is not just proportional, this is congruent. There's a little bit of a difference. We're starting out the same way. We have three parallel lines. So we're going to start out with the same if. If AE is parallel to BF, which is parallel to CG, then, well, we have here congruence. So we also have, we have to state that these two are congruent. So not only do they have to be parallel, there has to be a section that is congruent. So, and another stipulation, AB is congruent to BC, what that does is, because of our last theorem, making them proportional, if this side is proportional to this side, and this BC is going to be proportional to FG, because these are congruent, these are also going to be congruent. So it's sort of based on our last theorem. So we can say is then EF is going to be congruent to FG. Okay, let's put some of these into practice and apply them. Example 1, triangle RST. You know that RT and VU are parallel. You know that here's some of our side lengths. We want to find SU. So remember, this chapter is all about proportions. And we said in our first theorem that if their lines are parallel, then our parts are proportional. So 3/8 equals x/12. Cross multiply. And let's simplify. Divide by 8. And we find that SU is 4.5. And since it doesn't have a label, we say that it's just units. Okay, example 2. In triangle DEF, DH is 18, so let's go ahead and label that. HE is 36. DG is 1/2 of GF, which we can see right here. Is GH parallel to FE? So if this is X, this is going to be 2X. This is using the converse to triangle proportionality. We want to know, are these parallel? The only way we can prove that is if these sides are proportional. So, is 18/x proportional to 36/2x? Is that true? Yeah, that's true. So because it is true, we say yes by theorem 7.7. You could call it its name, converse of triangle proportionality, but I like to be short and sweet. So yes, it is proportional. Okay, example 3. We have here, we know that DE and EF are mid-segments. So keyword there, we're probably going to use the triangle mid-segment theorem. Mid-segment means that F is the midpoint of AB and D is the midpoint of BC. So that means that if this is 18, each of these is 9 units long. Okay? The mid-segment theorem says that if this is true, if these are mid-segments, which it is, then these mid-segments here are half the length. So ED is 1/2 of AB. So if ED is 5, how long is AB? AB is going to be 10. Okay. If we want to find FE, and it tells us that it is a mid-segment, that means it is half the length of BC. If this is 18, FE is 1/2 of that. So that makes it 9. Awesome. Now we have to find an angle. Angle AFE. AFE, this angle right here. Okay. So you have to remember, if it's a mid-segment, our mid-segment theorem says that mid-segments are parallel. So if these are parallel, this angle right here, 87, is now an alternate interior angle. So if this is 87, angle AFE is also going to be 87 degrees because it's alternate interior. Okay? Alright, example 4. Legacy Line and First Street, because the Legacy Lines are first. They are parallel to each other, so we have 3 parallel lines. We need to find x, so we're going to use the proportional parts theorem. If we have 3 or more lines that are parallel, and we do, we can make a proportion. 13 over 16 equals 26 over x. Now some of you may remember a shortcut to proportions, and that is, there's a relationship here. You can of course cross multiply, but I noticed that 26 is twice as big as 13. So x is also going to be twice as big. So x is going to be 32. Example number 5, our last example for 7-4. I need to find x and y. So this uses our last corollary, and that we not only have parallel lines, but we have congruent parts. These two segments are congruent. So to find x, I probably want to set those two equal to each other. 3x minus 7 equals x plus 5. Now I can just solve for x. Add 7. And then minus x. Divided by 2. X equals 6. There's x. Now I need to find y. Well, down here is our y's, and hey, they are also congruent to each other, so I probably want to make another set of equations congruent to each other. 9y minus 2 is equal to 6y plus 4. And let's add 2. And minus 6. and then divide by 3. And y is 2. And did I need to know the actual length of the segments? Nope, just find x and y. Get familiar with those theorems and corollaries. We're going to be applying them some more in lesson 7-5.